एवरीवन एंड वेलकम बैक टू द केम स्कूल। आई होप आपको याद है कि इस वीक हमने स्टार्ट किया था विद टॉटोमेरिज्म, तो आज हम लोग टॉटोमेरिज्म ही कंटिन्यू करेंगे, राइट। लास्ट वीक हमने सिर्फ इंट्रोडक्शन देखा था और हमने देखा था कि टॉटोमर्स हम कैसे ड्रॉ करेंगे। आज का हमारा ये मोटिव है कि अगर हम कीटो इनॉल टॉटोमेरिज्म कर रहे हैं तो कीटो ज़्यादा स्टेबल रहेगा कि इनॉल ज़्यादा स्टेबल रहेगा। अगर इनॉल ज़्यादा स्टेबल है तो उसके लिए क्या क्या फैक्टर्स या क्या क्या कंडीशंस होगा। Fine, so let's get started. Now, as you know, in the previous lecture, we said that the ketone form is usually going to be more stable. Now, why your ketone form is going to be more stable? Fine, because the energy of the ketone form is going to be less than your enol form. And we know that lower the energy, higher will be the stability. Clear? Fine. So, repeat the ketone form. And also remember that in ketone form, we are also talking about aldehydes. Okay. So, aldehyde and ketone both have C double bond O, and this together you can say that they are keto form. They are eligible to call as a keto form. So keto form usually have less energy and therefore they will have more stability than the enol form. But your equilibrium can also shift towards enol. That is, enol, if it is on the right hand side, we can say that the equilibrium is shifting towards the right hand side. And when can that happen? So let's talk about the factors when that can happen. So there are two major factors and there are three subtle factors, right? Subtle factors, or you can say small factors. So let's talk about the big factors first. The big factor is aromaticity and hydrogen bonding. We'll talk about them in detail. Okay, so bigger factor is aromaticity and hydrogen bonding. If you can observe them, okay, so in most of the cases, I didn't say all. Aromaticity, definitely. In case of aromaticity, if it is aromatic, it is always the enol form will be more stable. Okay, and next, hydrogen bonding, if there is there, most of the time it is going to be stable. Let's talk about the subtle factors. The subtle factors are conjugation, substitution, or solvent effect, right? So this you can study with respect to this also, right? Let's say you have conjugation and hydrogen bonding, so enol will be more stable. Okay, let's say you have more substitution and you have hydrogen bonding, so these factors along with this will help us to decide which one is more stable. So only we can understand this with respect to examples. So let's study each one of them in detail with help of example. Now we said that if you want to say that the enol is more stable, there are two big factors, right? Or two biggies. The first one was aromaticity. So let's understand this with the help of example. Have a look at this example, right? You can say that you have this two double bond over here, but you also have a ketone over here. So definitely you can see, not on this side, but on this side we can have tautomerism. Why? Because this is, with respect to ketone, this is alpha hydrogen, right? In this case, you will have two hydrogen. So we do know that. So let's not get into it. Draw the tautomeric structure for this. So how will you draw the tautomerism? Okay. So in this case, what you will have is, let's draw this. This is constant. This is not going to change. And we said that the double bond O we will write as OH. And towards the alpha hydrogen side, we will put a double bond. So you can see this is ene and this is OH, all. So enol, we have drawn enol. So this is keto and this is enol, right? Now have a look what is the major difference in both of the structures. This is not aromatic. It is conjugated. You have double bond, single bond, double bond, single bond, double bond. That is okay. But you can see that here there is no conjugation and therefore this particular structure is not aromatic. But in this case, you can see that you have a benzene ring, a benzenoid, right? And therefore this compound, we know that this is phenol, right? And we know that phenol is very, very stable. In such case, the phenol will almost be present, like you can say almost 100%. It is almost as good as 100%. Right? It means the equilibrium has completely shifted towards the right. So you can show this arrow, but do remember the real situation is like this. This is formed while this might be infinitesimally small, right? The quantity of this might be infinitesimally small. This is how the equilibrium is working. So if you have aromaticity, the energy of the system decreases to a very great extent, and if the energy is very, very less, the stability is going to be very, very more or high. Okay, so in this case, aromaticity thus decides that the enol is going to be more stable, or it is going to be a more formed form, okay, or more stable tautomer. Similarly, have a look at the next one. Can you draw the tautomer for this? Think for a while and then draw, okay? And do not see it before. So let's see what happens in this case. Again, if you want to draw the arrow, you can stick to this. This is no harm initially, okay? Now let's try drawing the structure for this. This ring will remain as it is, okay? Now what will happen? Draw the 6-membered ring first, okay? So for this carbonyl, you will take this alpha hydrogen, because here the carbon already have 4 valency, there is no hydrogen, so there is no point of drawing a double bond here. Why? Because the carbon will have 5 valency, which is not possible, okay? So move on this side. So if you move, put a double bond over here and a OH over here. This is tautomerism towards this side, but you can see that you have ketone over here also, and you have alpha hydrogen. So draw the tautomer for that also. So what you have is, again you will have this OH with the double bond. Now decide which one is more stable. Most of the students will say that there is benzene ring over here, so this should also be stable, okay? Yes, this also exists, that is not a problem, but this will exist at a much higher percentage. Why? Have a look. This is one benzene ring, while this is the other benzene ring. Double bond, single bond, double bond, single bond, right? Double bond and single bond. So this is naphthalene-like structure. So when you have one benzene ring, it is stable, but when you have 2 benzene rings, it is going to be more stable. Why? Because you have more conjugation. Is that clear? Fine. So even in this case, what will be the scenario? Okay, this will be formed at a much higher percentage than this. Is this clear? So we know the thumb rule that if the enol is aromatic, then it will exist at a higher percentage. That tautomer will be most stable. So ये fix हो गया सबके दिमाग में. This is very clear to all of you. Fine. So do know these 2 examples. In aromaticity, we will take 3 more examples so that the concept is completely clear. Okay. So have a look at the next example. In this case, if you want to draw the tautomer, how will you go? Go ahead. This already had a double bond, so it's no point going here, because 2 double bond together will make the structure highly unstable, right? So move on this side, right? So in this case, if you draw the tautomer, what will you get? Let's say double bond will remain as it is, right? This will become OH, right? Ketone ko OH में लिख देना है, and then put a double bond over here, because this is your alpha hydrogen, okay? This is what you get. Now decide which one is more stable. Now there's a very big problem in this example, and what is that? Check out. Whenever you have this type of system, I said count the pi electrons. How many pi electrons you have? So in this case, pi electrons are 4, right? I repeat, you have 4 pi electrons, and when you have 4 pi electrons, have written pi electrons, okay? So when you have 4 pi electrons, or when you have electrons in multiple of 4, okay, and the system is conjugated, I repeat, if the system is cyclic, it is conjugated, but the electrons are in multiple of 4, we know that that compound is anti-aromatic. And anti-aromatic compounds are highly unstable. Since they are highly unstable, this will not be formed at all. I repeat, this will not be formed at all. So if you talk in terms of percentage, this will exist 0%, while this will be 100%. Is this clear? It means no tautomerism takes place at this particular site. So remember, whenever you get from a non-aromatic compound or aromatic compound, if you're getting something called as anti-aromatic, remember that will not be formed, because anti-aromatic compounds are highly unstable and therefore they will not exist. Is this clear? Similarly, have a look at the next example. It's the same thing over there, right? In this case, if you draw the tautomer for this, what will you get? Okay, this part is aromatic, right? Now what are you drawing? Have a look. This will become OH, while here you will get a double bond. So this was aromatic, but have a look at this side. Okay, this is having double bond, single bond, double bond, single bond. This is anti-aromatic, or you can count the total number of pi electrons. So it is 3 plus 1, 4 pi bond. So pi electrons will be double of that. That is, you have 8 pi electrons. Again, the system is anti-aromatic. And when it is anti-aromatic, no tautomers will be formed. I repeat, when it is anti-aromatic, no tautomers will be formed. So no tautomerism will be shown by this particular ketone. Okay, do remember that. Okay, have a look at the next one. Now this is a special case, and in this case you have to decide like how many enols you will get, and from the enol you get which one is more stable. Okay, so whenever you have a carbon which is between two rings, I repeat, whenever you have a carbon which is between two rings, such type of carbon are called as bridged carbon. I repeat, such type of carbon is called as bridge carbon. Is this clear? Fine. So this is what you should know first. So here you have two bridge carbons. So these are two different rings, and this carbon is between two different rings. This carbon is between two different rings. So you have two bridge carbon at this particular site. Okay. Now draw the tautomers for this. When you draw the tautomers, the first tautomer, okay, decide. We'll just make some more space. Okay, draw this. This type of compounds are called as pyro compounds. It is not important for us as of now. We'll just solve. Okay, so decide how many alpha carbons you have and where. Okay, so this bridge carbon is also alpha and it has one hydrogen. We know that this has one hydrogen. Okay, while here you have two hydrogens. Okay, so as of now, this is alpha, this is alpha, this is alpha, and this is also alpha. Oh, sorry, there's no functional group over there, so we will not take for that. Okay, so this is all the hydrogen you have. With respect to ketone, this is alpha and this is alpha. This is what we should know. Now, where will you draw the double bond? If you draw the double bond over here, there's a problem. What? I hope you remember something called as Bayer's strain, right? And it talks about bond angle, right? If you talk about this particular carbon, it is sp3 hybridized. Why? 1, 2, 3, 4, 4 sigma bond, right? So this bridge carbon is sp3 hybridized. Usually in sp3 hybridization, the bond angle is 109 degrees, 28 minutes, fine? So just remember 109 degrees. In this position, if you check, now your bond angle is strain, right? There is a lot of strain in this particular compound, right? So in this case, this particular bond angle is 60 degrees, right? Okay, while this particular bond angle will be different, this particular bond angle will be different, and this particular bond angle will be different. So this is sp3 hybridized carbon, but it has different bond angles. This was still okay, that this particular carbon was in a lot of strain, but if I put a double bond, right, this particular bridge carbon now is sp2 hybridized. For sp2 hybridized, you know that the bond angle is 120 degree. Have a look what you have done. This particular structure is now bent so much that this cannot exist. So bridge carbon पे हम double bond नहीं डालते. Whenever you have a bridge carbon, if you put a double bond over there, the strain will increase, right? The Bayer strain will increase. The bond angle will not be, stable, and therefore the molecule will break. So we do not draw such type of structure, right? So this type is unstable. Is this clear? So you will not draw this. So this is gone. So let's talk about the other possibility that you can have. Okay, so it means if you are not taking this alpha hydrogen, you have to go for this alpha hydrogen. So put a double bond on the other side. Now it is fine. Why? Because it is not towards the bridge carbon. The double bond is almost on the opposite side. So this enol will be more stable than this enol. So whenever you have a comparison, just remember, towards the bridge carbon, no double bonds. Okay, just move on the other side. So in this two enol, this enol is going to be more stable. I'm talking in between enols. Okay, I'm talking in between enols. This enol is going to be more stable. I hope this is very clear to all of you. Okay, so जो second bigger factor है, that is hydrogen bonding. Again, let's understand it with help of example. तो यहाँ पे मैंने डाइकीटोन ड्रॉ किया है एंड यू कैन सी दैट इट इज़ 2,4 डाइकीटोन, ठीक है। तो ये पेंटेन डायोन है, ठीक है। तो पेंटेन डायोन में अभी हम लोग देख लेते हैं कि अब टॉटोमेरिज्म कैसे एग्जिस्ट करेगा। तो इसका टॉटोमर जो है मैं ड्रॉ कर लेती हूँ। वन मोर थिंग रिमेंबर कि हम लोग ये CH3 और ये CH3 को भी यूज़ कर सकते हैं टॉटोमर ड्रॉ करने में, लेकिन हमको पता है कि दो कीटोन के बीच में जो CH2 होता है, रिपीट, दो कीटोन के बीच में जो CH2 होता है, ठीक है, दैट इज़ मोर एसिडिक। यहाँ पे जो हाइड्रोजन है दैट इज़ मोर एसिडिक। अगर ये हाइड्रोजन ज़्यादा एसिडिक है कंपेयर टू इन हाइड्रोजन के, तो आपको इसी हाइड्रोजन को विड्रॉ करना चाहिए सो दैट यू गेट मोर स्टेबल टॉटोमर। So I repeat, more stable tautomer आपको कब मिलेगा? When you take more acidic hydrogen. So just take care of that, ठीक है? And that is the reason I'm not drawing the tautomer with respect to this two CH3. तो ये सेंटर का देख लेते हैं, fine. So what will you get? You will get CH3, okay, OH, right, double bond, and ये कीटोन ऐसे रहेगा. Again you will have CH3 over here, fine. Symmetrical structure है, therefore if you draw enol over here or you draw a enol over here, it's one and the same, okay. तो ये एक particular structure हो गया. So I repeat, एक structure तो हमने draw नहीं किया, that is we haven't considered one double bond at first sight. Why? Because this is more acidic, ठीक है. एक वो, दूसरा ये structure, और एक possibility था यहाँ पे, that is आप दोनों भी double bond को convert कर दो enol में, fine. In that case what you will get, let's say you are drawing enol over here, ओके. नेक्स्ट यहाँ पे OH अगर आपने लिया तो आपको डबल बॉन्ड यहाँ पे लेना पड़ेगा, ओके. ये एक पॉसिबिलिटी हो गया, फाइन. बट रिमेंबर कि ये भी बन सकता है, ये भी बन सकता है. अब ये दोनों केसेस में स्पेशल क्या है, हैव अ लुक. इन दिस केस यू कैन सी दैट ये H जो है दैट कैन गो विद दिस ऑक्सीजन. वाई? बिकॉज दिस ऑक्सीजन हैज लोन पेयर. अगर ये ऑक्सीजन के पास लोन पेयर है और बाजू में आपके पास OH आ गया, सो इन दिस केस यू विल हैव समथिंग कॉल्ड एज इंट्रा मॉलिक्यूलर H बॉन्ड. एंड यू नो दैट जैसे एरोमेटिसिटी में एनर्जी बहुत कम होता है, वैसे अगर हाइड्रोजन बॉन्डिंग होता है तो भी आपका एनर्जी ऑफ द सिस्टम डिक्रीजेस अ लॉट. तो यहाँ पे इंट्रा मॉलिक्यूलर हाइड्रोजन बॉन्डिंग की वजह से आपका एनर्जी क्या हो गया, काफ़ी कम हो गया, फाइन. अपार्ट फ्रॉम दैट ये केस में क्या हो गया, आपके पास डबल बॉन्ड, सिंगल बॉन्ड, डबल बॉन्ड. चेक करो, यहाँ पे दो डबल बॉन्ड के बीच में दो सिंगल बॉन्ड था, मतलब यहाँ पे कॉन्जुगेशन नहीं था. जबकि ये वाले सिस्टम में हाइड्रोजन बॉन्डिंग के साथ क्या आपको मिल रहा है, कॉन्जुगेशन भी मिल रहा है, फाइन. दिस इज कॉल्ड एज एक्सटेंडेड कॉन्जुगेशन. So you have two factors which is going to stabilize your enol more than your ketone, fine. So in this case again the arrow will be your enol is much more stable than your ketone. Is this clear? Similarly ये वाले केस में भी आपका हाइड्रोजन बॉन्डिंग होगा, यहाँ पे भी डबल बॉन्ड, सिंगल बॉन्ड, डबल बॉन्ड, यहाँ पे भी एक्सटेंडेड कॉन्जुगेशन है, ठीक है. बट कीटोन एंड अल्कोहल में जो हाइड्रोजन बॉन्डिंग होता है वो ज़्यादा स्ट्रॉन्ग होता है कंपेयर टू OH, फाइन. तो अभी ये केस में ये जो रिंग बना है यहाँ पे 6 मेंबर रिंग बना है वो ऑलमोस्ट कांस्टेंट रहेगा, ठीक है, ऑलमोस्ट कांस्टेंट रहेगा. इसकी वजह से इसका स्टेबिलिटी ज़्यादा होता है कंपेयर टू दिस पर्टिकुलर स्ट्रक्चर. आई डिडंट से दैट दिस इज नॉट स्टेबल, दिस इज ऑल्सो स्टेबल, बट दो इनॉल बनेगा इसका पॉसिबिलिटी कम होता है, फाइन. आई रिपीट, यहाँ पे ये दोनों कीटोन इनॉल में कन्वर्ट हो जाएगा, इसका पॉसिबिलिटी ही कम होता है. दैट इज द रीजन दिस इज गोइंग टू बी योर मेजर कंपाउंड, fine. So I repeat, in this case this enol is going to be more stable. Is this clear? Fine. तो ये अच्छे से याद रखना. Now अब हमने बोला था दो मेजर फैक्टर के साथ there are 3 subtle factors that also decide which particular tautomer is going to be more stable. So let's talk about the 3 subtle factors. Now in this particular example you can see that you already have a benzene ring, right? Apart from that you have CH2, C double bond O and CH3, right? Now if you draw the tautomer for this, which tautomer is going to be more stable? Let's draw first one, that is okay. So in this case this is also alpha, right? This is alpha and this is also alpha. And I repeat, कार्बोनाइल के बाजू वाला जो 2 कार्बन है वो अल्फा कार्बन है एंड दे हैव हाइड्रोजन. दिस इज CH2 एंड दिस इज CH3. दे हैव हाइड्रोजन. सो यू कैन ड्रॉ द डबल बॉन्ड ऑन आइदर साइड. सो लेट्स कंसिडर दिस वन फर्स्ट, ओके. सो इन दिस केस व्हाट यू विल हैव, डबल बॉन्ड, यहाँ पे आपको OH मिल गया एंड दिस. सिमिलरली ड्रॉ द नेक्स्ट वन, व्हाट यू विल गेट इज Okay, so now if you consider this alpha, what you will get is this is OH and double bond over here. अब आपको एक्सटेंडेड कॉन्जुगेशन मैंने इसके पहले एग्जाम्पल में भी थोड़ा सा समझा दिया था, ठीक है. तो अब यहाँ पे वही चीज़ देखो और अप्लाई करने का ट्राई करो. इन दिस टू एग्जाम्पल यू कैन चेक. यहाँ पे डबल बॉन्ड सिंगल बॉन्ड सिंगल बॉन्ड डबल बॉन्ड सिंगल बॉन्ड, मतलब यहाँ वाले पार्ट पे आपका कॉन्जुगेशन नहीं है, ठीक है. तो ये आपका कीटोन फॉर्म था, लेकिन यहाँ पे चेक करो, डबल बॉन्ड सिंगल बॉन्ड डबल बॉन्ड सिंगल बॉन्ड, यहाँ पे आपका कॉन्जुगेशन हैज़ इंक्रीज्ड बाय 2 कार्बन्स. आई रिपीट, ये ऑलरेडी कॉन्जुगेटेड सिस्टम था, लेकिन अपार्ट फ्रॉम दैट इसके बाद 1 2 यहाँ तक आपका कॉन्जुगेशन क्या हो गया, एक्सटेंड हो गया. तो यहाँ पे आपके पास क्या है, एक्सटेंडेड कॉन्जुगेशन. क्लियर. बट हैव अ लुक एट दिस वन. यहाँ पे वापस से यू हैव डबल बॉन्ड के बीच में सिंगल बॉन्ड एंड देन डबल बॉन्ड. तो यहाँ पे कोई एक्सटेंडेड कॉन्जुगेशन नहीं है. फाइन. तो यहाँ पे आपका कॉन्जुगेशन नहीं है. एट दिस पर्टिकुलर पार्ट नो कॉन्जुगेशन. ओके, हम ऐसा ड्रॉ नहीं करेंगे बिकॉज कोऑर्डिनेशन का पार्ट में उसका मीनिंग कुछ अलग रहता है. बट फिलहाल के लिए ये वाले पार्ट में आपको कॉन्जुगेशन नहीं मिल रहा है. देयरफॉर इन दोनों इनॉल में से ज़्यादा स्टेबल कौन सा होगा, दिस पर्टिकुलर इनॉल. फाइन. सो दिस इनॉल इज स्टेबल. ओके, what else? This enol is formed at a higher percentage compared to your ketone form. Okay, right? तो इसका percentage भी ज़्यादा है compared to your ketone. Is this clear? Fine. तो आपको ये समझ में आना चाहिए कि extended conjugation भी आपका enol form को stability ज़्यादा दे सकता है. Now let's talk about the effect of substitution. अब substitution कब आपको help करेगा, आपको ये बताने में help करेगा कि कौन सा ketone का enol जो है वो ज़्यादा stable होगा. Fine. और it means किसका टॉटोमर ज़्यादा फॉर्म होगा. तो हैव अ लुक, यहाँ पे मैंने 2 कीटोन लिया है, दैट इज ए एंड बी. इन दिस केस अगर इसका टॉटोमर आपने ड्रॉ किया, सो व्हाट विल यू गेट. सी इन दिस केस this also has alpha hydrogen and this also has alpha hydrogen. So double bond can be formed over here and double bond can also be formed over here. But आपको पता होना चाहिए that substituted alkenes are more stable. I repeat, we know that substituted alkenes are more stable. Okay, so just remember this statement that substituted alkenes are more stable and therefore substituted alkenes ही बनाते हैं हम लोग. तो यहाँ पे डबल बॉन्ड डाल सकते हैं और यहाँ पे डबल बॉन्ड डाल सकते हैं, तो हम लोग यहाँ पे डालेंगे. क्यों? क्योंकि ये substituted वाला पार्ट है. फाइन. सो इन दिस case what you will get is this. Clear? Whether in this case there is no substitution, so you can draw the alkenes, that is not an issue. But now decide which alkene is more stable. This alkene is more stable or this alkene is more stable. So we know that substituted alkene is more stable. Therefore, this will be more favored. So from this, let's say this is C and this is D. C will be more stable. Why C will be more stable? Because it is a substituted alkene. So this is how this type of question will be asked. Okay. So remember that alkenes which are tetra substituted are more stable. तो stability of alkene हमको पता है, लिख देती हूँ मैं, चाहिए आपको तो वापस. Stability of alkene I am talking about. Okay. So just remember that. So stability of alkene में tetra substituted more stable than tri-substituted. Okay. Then di-substituted alkene and least stable will be mono-substituted alkene. Why? Which reason do you think is eligible for this? The reason is hyperconjugation. I repeat, the reason is hyperconjugation. You know that if you have more alpha hydrogen, I repeat, if you have more alpha hydrogen, you will have more hyperconjugation. So where can you have more alpha hydrogen? When you have more substitution. So tetra substituted, if they have more alpha hydrogen, then the compound will be more stable. Similarly, tri-substituted alkene with more alpha hydrogen will be more stable, followed by di and followed by mono substitution. So do check out for this even in hyperconjugation. I will attach the link below. Okay. So minor factors या फिर subtle factors में थर्ड वाला देख लेते हैं, that is effect of solvent. अब effect of solvent बहुत इंपॉर्टेंट होता है in organic chemistry because they can decide a lot of things कि आपका reaction जाएगा या नहीं जाएगा, whether your reaction will take place or it will not take place. Fine. So have a look what effect it has on tautomerism. Now if you remember this डाइकीटोन एग्जाम्पल थोड़ी देर पहले हमने ड्रॉ किया था एंड हमने बोला था कि ये केस में आपका इनॉल फॉर्म क्या रहेगा, ज़्यादा फॉर्म होएगा या ज़्यादा स्टेबल होएगा. फाइन. एंड परसेंटेज के टर्म्स में देख लेते हैं व्हाट डज दैट मीन. सपोज देयर इज नो सॉल्वेंट. नीट अगर आपने केमिस्ट्री में यूज किया मतलब देयर इज नो सॉल्वेंट. फाइन. सो देयर इज नो सॉल्वेंट. इन दैट केस योर कीटोन फॉर्म विल बी 24% एट, लेट्स से वी आर टॉकिंग अबाउट समथिंग बिटवीन 20 to 25 डिग्री सेल्सियस. ठीक है. तो या फिर आप बोल सकते हो एट रूम टेम्परेचर. तो आपका कीटोन फॉर्म का परसेंटेज इज गोइंग टू बी 24% while your enol form percentage will be 76%. Neat, there is no solvent. But if I take benzene, now remember that benzene is a non-polar solvent. Okay, benzene is a non-polar solvent. It means if I take a non-polar solvent, in that case also your enol will be favored. In fact, the percentage of enol will keep on increasing. Why? Now, because the hydrogen bonding will be more favored. Okay, intramolecular hydrogen bonding अगर आपको increase करने का है, so to increase intramolecular hydrogen bonding, you should have more non-polar solvent. Why? Because the solvent will not interfere in hydrogen bonding. Okay, so that the molecule can couple with itself or the molecule can have hydrogen bonding amongst itself. So if I take a non-polar solvent, in that case you can see that the ketone form is 6% only. It has decreased from 24% to 6%, while the enol form has increased from 76% to 94%. But if I take something called as a polar protic solvent, water is polar plus it is protic. In this case, it was non-polar plus it was aprotic. Okay, so if I take a polar protic solvent, then in that case what will happen? This water will also undergo hydrogen bonding with the ketone. Okay, I repeat, the water will undergo hydrogen bonding with the ketone, and even if this is formed, okay, it will undergo hydrogen bonding with this also. So now water is interfering with both of them. Okay, now when water starts hydrogen bonding with the ketone, it means the enol will not be easily formed, and that is the reason the percentage of ketone will be more. Have a look, it is 81%, while enol is formed to a very good quantity, still 19% is still more. Do you remember about the phenol? In that case it was 99.99999, or you can say it was almost 100%. Here it is almost like 19%, or you can say 20%, which is still a substantial amount for enol. But still you can note that a solvent has decreased the tautomerism to a very great level. So the effect of solvent is also very important. Fine. So remember that whenever you are talking about hydrogen bonding, you should have non-polar and aprotic solvent, so that your enol is favored or enol is formed at higher percentage. So do remember this while solving all the MCQs. See you soon in the next class.